Hello and welcome to Mr. Quinn Maths. Today we're going to be looking at the topic of surds within the C1 course, and we're going to be rationalising the denominator fraction. So let's have a look. So here's a question. It's asking us to rationalise the denominator of this fraction. So basically what we have to do is remove the surd from the bottom of the fraction. We do not like to leave surds at the bottom of our fraction, so we have to rationalise this denominator. Feel free to pause this video and have a go at it yourself. Okay, now in order to rationalise the denominator of this fraction, what we must do is multiply the fraction top and bottom by 1 minus root 2. Now this is the same as 1 minus root 2 over 1 minus root 2. So we are just basically multiplying it by 1, so it will not change the value, but it will change how it is displayed. So let's have a go at this. The next step is to expand and simplify the bottom line of this fraction, the denominator. So there are a number of different ways we can do this. The method I will show you here is the box method. So we must write one bracket along the top of the box and the other bracket along the side. And then we multiply each of the terms. 1 to 1, root 2. 1 times minus root 2 is minus root 2. Now, here we have minus root 2 multiplied by root 2. This gives us negative 2. So we can now group all the terms together. So we have 1 minus 2, which is minus 1. And we have root 2 minus root 2, and they will cancel out. This can then be simplified to minus 1 minus root 2, which is equal to root 2 minus 1. Or you could have left it as minus 1 plus root 2. Okay, another question here. We're asked to rationalise the denominator of this fraction. So basically the same principle as before. We're trying to remove the surd from the bottom of the fraction. Feel free to pause and have a go at it yourself. So in order to remove the surd from the bottom of the fraction, what we must do is multiply this fraction top and bottom by 1 plus 2 root 3 over 1 plus 2 root 3. This then gives us 5 plus root 3 upon 1 plus 2 root 3 over 1 minus 2 root 3 upon 1 plus 2 root 3. So it's at this stage we can expand and simplify the top and bottom line, and I'm going to stick with the box method here. So we add one of the brackets to the top and the other to the side, and we multiply each of the terms. 5 times 1 is 5, 1 times root 3 is root 3, 5 times 2 root 3 is 10 root 3. Now here we have 2 root 3 times root 3. This gives us 2 times 3, which is 6. Root 3 times root 3 is 3. Now we will do the same to the bottom line of the fraction, and we're hoping that when we expand and simplify here, it will remove the surds. One times 1 is 1. We get minus 2 root 3 here, 2 root 3, and here we have a negative 12. So let's rewrite this. Our top line can now be simplified to 5 plus 6, which is 11, plus 10 root 3 plus root 3, which is the same thing as 11 root 3, all over our bottom line here, which will be minus 11, and here we have the minus 2 root 3 add 2 root 3, they will cancel out, so that leaves us with 11 plus 11 root 3 over minus 11. One final step here, the 11s will cancel out, so we have 1 plus root 3 over minus 1, which then gives us minus upon 1 plus root 3, which is equal to minus 1 minus root 3. Here we have two more questions. Feel free to pause and have a go at them yourself. The first question, we have to express this fraction in the form a plus b root 5, where a and b are positive integers. Okay. 5 plus 5 plus root 5 over 3 minus root 5. Now, again, if we multiply this fraction top and bottom by 3 plus root 5, this will rationalize our denominator. We then have 5 plus root 5 upon 3 plus root 5 all over 3 minus root 5 upon 3 plus root 5. Again, if we expand out the top line using the box method, we multiply each of the terms here. 3. 5 times 3, 15, we get 3 root 5, we have 5 root 5, and we have root 5 times root 5, which gives us 5. The bottom line we can expand out now, so we have 3 minus root 5, 3 positive root 5. Multiply each of the terms here, so we have 3 times 3, which is 9, we have minus 3 root 5 here, we have 3 root 5, so we can see that those two terms will cancel out. And we have root 5 times minus root 5, which gives us negative 5. So let's add that in. So our top line simplifies to 20 plus, so we have 3 root 5 plus 5 root 5, which gives us 8 root 5. And we're dividing that by 9 minus 5, which is 4. You can see that the minus 3 root 5 and 3 root 5, they cancel out. Okay, one final step here. We can divide 3 by 4. That simplifies to 5 plus 2 root 5. Therefore, a must be equal to 5 and b must be equal to 2, and they are both integers. In the next question, we're asked to rationalize the denominator of this fraction. Once again, if we multiply the top and bottom of this fraction by 3 minus root 7 over 3 minus root 7, this should rationalize our denominator and remove the surd from the bottom of the fraction. We have 2 upon 3 minus root 7 all over 3 plus root 7 upon 3 minus. So there's a mistake here. The 3 is obviously meant to be the 7. This then gives us 3 minus root 7. Expanding out the bottom line here, we have 3 root 7 upon 3 minus root 7. This gives us 9, 3 root 7 minus 3 root take again, root 7, gives us negative 7 here. Now you'll notice that the surds will cancel out here within the box. So that leaves us with 6 minus 2 root 7 all over 9 minus 7, which is 2. One final step here, we can divide through by 2. That gives us 3 minus root 7. Now, just to conclude, there are a few things I think it's worthwhile pointing out. The square root of AB is equal to root A times root B. So just an example here, root 15 is equal to root 5 times root 3. Root A over B is equal to root A over root B. And an example of that, root 49 over 9 is equal to root 49 over root 9, which simplifies then to 7 over 3. Okay. You could now try exercise 1F on page 13 of the SIA AS book. There's also a couple of very useful videos from Mr. Heggerty Maz in YouTube, Rationalising Surds, that you could check out.